So after that we have capillary beds, which are the set of capillaries that you're going to find in between the venule and the arteriole. So the blood flows this way and it goes through the capillaries, from the capillaries to the cells, and from the cells to the capillaries. So let's keep going down, and we can see now the veins. So we talk about the arteries, we talk about the capillaries, we are going to talk about the veins in this case. So the veins, large veins, medium veins, and small veins. There's other sizes kind of like in between, as you can see here. So we said we have the venules, then you have muscular venules. These are going to be small. Then you have the medium vein. You can see here it has the valves that we already talked about it. You have venous sinuses, it's like the coronary sinus, and then you have the large veins. For example, large vein obviously is going to be the superior and inferior vena cava. So if we scroll down, we have circulatory routes. We said the blood comes from the heart through the aorta into the multiple different organs. Right here you have anastomosis. Anastomosis are connections in between multiple different blood vessels. Okay, so we go down here and we say we have anastomosis, and that's about it for this part. The next topic is blood pressure, resistance, and flow. So blood vessels, what they do is they supply the organs with blood, and obviously they are going to allow blood flow, which is the amount of blood that goes through a specific organ. Perfusion is the amount of blood that goes through an organ from the organ perspective. For example, you have the bone and you have the ovaries. So let's say we have 5 liters of blood. 5 liters of blood goes through the bone, 5 liters of blood goes through the ovaries. But overall, the ovaries have a smaller size than the bone. Therefore, the ovary gets the 5 liters, but the perfusion, which is the amount of nutrients and oxygen that it's going to get, is more than the amount of nutrients and oxygen that the femur, for example, is going to get. Why? Because the femur is big, so therefore the amount of perfusion is going to be less. We scroll down, we can see blood pressure. You have systolic pressure and diastolic pressure. The difference between the two is the pulse pressure, mean arterial pressure, which is not the average, but rather 1/3 of diastolic and the pulse pressure. So we keep scrolling down, and you can see here, obviously, systolic pressure is higher than diastolic pressure. They are talking about atherosclerosis. Atherosclerosis is the hardening of your blood vessels over time. Your blood vessels can expand and contract a little bit, and that's going to help us maintain the blood flow that happens at the level of the blood vessels. However, as we get older, this small elasticity that the blood vessels are going to have disappears because the blood vessels become rigid, not only because of aging, right, but also because of atherosclerosis. So that's why, since the blood vessels become rigid, they lose this elasticity that they have. Their blood vessels cannot expand. Therefore, most of the time in old people, for example, the blood pressure increases. So how do you call this increasing pressure? Hypertension. And we also have hypotension. Usually blood pressure higher than 140/90 is considered hypertension. So now, what determines your blood pressure? Cardiac output, blood volume, and resistance. Blood volume is part of your cardiac output, and resistance is the forces that will stop this blood from flowing. So we have peripheral resistance. What's the peripheral resistance? Are all those forces that are going to stop the blood from flowing. So what are these things? Blood viscosity. If the blood is thicker, if the blood is more viscous, then obviously that's going to slow down the blood flow. Therefore, will affect your blood pressure. And that's why it says in here, erythrocyte count is important, because if you have a lot, then the blood will flow slowly, but if you have a little, then the blood is going to flow faster. Vessel length is a very long blood vessel. It's a very long tube. So the longer the tube it is, the less blood flow you're going to have. So therefore, the vessel length also affects your peripheral resistance. Next one, blood vessel radius. The smaller the blood vessel, the more resistance you have. The larger the blood vessel, the less resistance you're going to have. When the blood vessel, for example, has certain length and you make it smaller, then that's going to be vasoconstriction. And if it's smaller and you make it larger, that's going to be vasodilation. So as you can see here, the blood vessel has a larger area right here. So then this is going to produce less resistance than if this one is smaller. If you keep scrolling down, regulation of blood pressure and flow, you have local control. For example, if you have an area that is going to have low blood for whatever reason, then you're going to start accumulating carbon dioxide. If you have a lot of carbon dioxide, then the pH will drop, so that area is going to become acidic. So therefore, that's going to trigger vasodilation of this area, so you can get more blood in there, so you can eliminate the carbon dioxide and increase the pH in those areas. obviously the amount of blood that is going to be in that area, because you're going to produce vasodilation, a lot of times that's called reactive hyperemia. Angiogenesis is the growth of more blood vessels, because if you lack oxygen, one way that you can do the opposite is that providing more blood vessels in that area to give them more oxygen. Neural control, our brain can control the amount of blood that you're going to get in different areas, because we have baroreceptors and we have chemoreceptors. You have baroreceptors, chemoreceptors. You just need to know that you have baroreceptors and chemoreceptors. The baroreceptors are going to increase or decrease the blood pressure according to your metabolic needs. Same thing with chemoreceptors. You have carbon dioxide, you have oxygen. The more carbon dioxide you have in certain areas of your body are going to allow you to increase or decrease the blood pressure. Ischemic reflexes, that's your brain. If your brain senses that you have low levels of oxygen in your brain, then your brain immediately is going to trigger baroreceptors to increase the blood pressure and therefore to increase the blood flow in your brain, so your brain can get the necessary amount of oxygen that it needs. Again, chemoreceptors, we've talked about carbon dioxide already. Medullary, as I was telling you, this is for the brain.